Now I am going to talking about the advanced manufacturing methods and techniques. I am Professor Alikesh Manna, Department of Mechanical Engineering, Punjab Engineering College, that is PEC University of Technology, Chandigarh. So now the manufacturing process. What is manufacturing process? First we will describe and then we'll go for one by one to the describe, I think you have no audience in here, no? That is only the one people you are. So I think you please sit over here. That will be better. You should over here. You can sit here. Yes, that is better. You can sit. So manufacturing is a process or processes with combination of technique and methods to convert the raw material into product, may or may not be finished product, but convert into the product through product design, selection of raw material, utilization of proper machine, tooling system, methods, techniques, whatever may be, and man also. So product to be manufactured. So this is the lot of things are involved with the manufacturing definition. So here one of the important thing is the product design also. That means you are going to whatever maybe you are going to manufacturing, that must have to be your thing first. So maybe based on the whether existing product or maybe something new. So that you have to think something and that concept had to be clear in the form of sketch and then sketch convert into the drawing with some dimensions. And that with mentioning some tolerances, that dimension and tolerances, so-called known as drawing, and that based on the drawing you have to manufacture from a raw materials, whether in the blank form or whether you have to manufacture the raw material itself, and then ultimately you're going to make the finished product. So nowadays is the whatever may be the conventional or traditional machining method, manufacturing methods are may not the sufficient because of some advanced materials are developed by the present researchers, scientists and metallurgists. So we have to use some advanced methods. So I'm going to discussing this today. Say what are the advanced manufacturing? So advanced manufacturing is nothing but that it is a most widely used. The definitions of advanced manufacturing involves the use of technology to improve the product and or processes, with the relevant technology being described as advanced, innovative or cutting edge. That is basically a use of innovative technology to improve the product or process. So the various definitions the people have given in the many areas. So Virginia Beach Economic Development Department defines the advanced manufacturing as industries that increasingly integrate new innovative technologies in both products and processes. The rate of technology adoption and the ability and the adoption to use that technology to remain competitive and add value define the advanced manufacturing sector. And the National Association of Advanced Manufacturing state the advanced manufacturing enters upon improving the performance of industry through the innovative application of technologies, processes and methods to product design and production. Then means product design is one of the important thing which is very much important for selection of, based on this product design, it is you have to select the processes, whether it is advanced process is required or the conventional process can be sufficient to manufacture effectively and economically. That is also another important point. Now, even recent survey of advanced manufacturing definitions by the White House, a concise definition of advanced manufacturing offered by some in manufacturing that entails rapid transfer of science and technology into manufacturing products and process. The advanced manufacturing entity makes extensive use of computer, high precision, and information technologies, integrated with a high performance interface in a production system capable of finishing a heterogeneous mix of products in small or large volumes with both of efficiency of mass production and the flexibility of custom or customer requirement or custom in manufacturing in the order to respond quickly to customer demands. That means it is very clear. So it is nothing but that there have a, with the aid of the computers and information technology, with the NCCNC platform, these are the advanced machines and system come into across, can utilize to make the precision product with precision. That means very good accuracy, even in the very your micron and nano level size and dimensions, and can utilize with economically to fulfill the customer requirement. So again, according to the President's Council of Advisory on Science and Technology report to the present on emerging American leadership in advanced manufacturing is a family of activities that depends on the use of coordination of information, automation, computation, software, sensing and networking. Lot of things are there. That is a coordination of everything. Information, automation, computation, as well as use some softwares, many things, even sensing, there's a acoustic emission sensing. So that can be used for measurement or monitor of this cutting tool we are during event turning. So this is an example. So that type of things we can monitor, even measurement side by side to make the precision or highly accuracy product with a less time, that is less cost, and also make use of cutting tool materials and emerging capabilities enabled by the physical and biological sciences. For example, nanotechnology, chemistry, biology, there's a biomedical plants, even a manufacturing of knee for replacement of the knee in the medical science, so that the kneecap are also nowadays is made of some steel material which is become machining by the advanced cutting tool and methods, and even advanced manufacturing, that is finishing advanced, it is Armstrong level finishing, that also can be possible to achieve by some abrasive flow finishing, magnetorheological abrasive flow finishing, a lot of finishing process, that is advanced machining methods. These involve both new ways of manufacturing based on the existing products, and especially the manufacturing of new products emerging from new advanced technology. So these are the important things in advanced technology. Even product characteristics in advanced technology, say products from high level of design, technologically complex products, innovative products, reliable, affordable, and available products, that is also very much important. And newer, that is newly, not the exactly some modification of the existing, better, more exciting products, and products that solve a variety of society's problems. That means the society needs today. So today, just like it is required some measurement of your blood thinner, that is INR in the blood. So that can possible to measure if you become use some specific instrument. Otherwise, laboratory have a machine, you have to pay the 500 rupees at least for a sample testing. But if you develop something in a prototype level or in a small miniature level of the complete machine, that can possibly use in the home and can measure the INR value of the blood. So this is the new things that are required to be the advanced machining or advanced process for manufacturing of such kind of product, which is very much the required or needed in the present market by the society. So the advanced manufacturing research has been turned into following three categories. The research, one is cross-scale manufacturing technologies, that is working with advanced nano machining and fabrication. Studying the characteristics of the advanced materials for manufacturing, tribology, that is friction, lubrication, wear, all are become today's are important to be uh, considered individually or together, or their interaction to achieve the precision and the quality of product. So large scale numerical analysis also is also important on the product, and so that we can achieve the good and acceptable product or better product. Sustainable manufacturing, that is also important and area, including the improving of the product life cycle, developing new sustainable manufacturing technologies. That is life cycle of the product, because every product we need some your warranty or guarantee period. Otherwise, it is very difficult to sell in the market, so that with a very low cost. So that is sustainable manufacturing is an area which is required to be also researched, which is in a come into the advanced manufacturing, involving the energy efficiency of manufacturing process, carbon footprint and life cycle assessment. Everything are also important, which is required to be analyzed through research activities. Even manufacturing management and lean manufacturing, that is also important because of the cost involved. Manufacturing costs are directly involved in the manufacturing, basically because raw material cost you cannot reduce, you cannot compromise with this. Even you can only the compromise with the cost of manufacturing by reducing the wastage, or by zero wastage, or by you can say zero lead time, and all these things you can, or you can reduce it by the labor hours, and all these things are required to some of the supply chain management, engineering, assets, liabilities, and quality analysis, and involvement of manufacturing and operations. So that means the whatever may be the infrastructures are available with you, that you have to be analysis properly, used optimally properly. How you can use optimal infrastructures available with you, so that can the manufacturing cost can be reduces, wastage can be zero, and reduction or failure can be zero. So that is a part of also required in the advanced manufacturing research, and so that can improve the product. Now micro manufacturing, that is also another important aspect. So micro manufacturing presently more focused on miniaturization. Miniaturization means it is, this is the dimensional. Dimensional should be less than 1 millimeter. So it is required, many of the products or part or spare parts are required to manufacture, which is become important, used in the assembly system for a particular product. That means downscaling both conventional and non-conventional methods to produce micro product. Downscaling, size is reduces. So today you people have seen, say the mobile phone are very small, but all activities we need, all sort of activities, not only the modulation, demodulation, not only receiving and communicate the our sound, but also the pictures, and as well as other calculations, numericals, storing, and all this. So therefore we need all of the platform in a single chips. So that single chips is also important, how you manufacture. Through the micro manufacturing system we can manufacture. So the based on the energy used, we can segregate in the mechanical, chemical, thermal, electrochemical, electrical, laser, etc. processes. These are the includes in the micro manufacturing, or you can classify it in such a way. Based on working principle by mechanical process, thermal effects, ablations, dissolutions, solidifications, recompositions, polymerization, lamination, extra lot of processes are involved over here. So the process are basically ablation is a process or the removal of material by from the solid surface. It is a process of removal of material from the solid surface by excitation or by irradiating or irritations, irradiating or it with by some means. Maybe it is by use of laser, so it is called the laser ablations, or by call some heating surfaces, or by chemical reactions. So chemical ablations and all these processes are very much important for removal of all these. There's a diffusion process also. Diffusion is also another important, refers to process that tendency of molecules to spread out as a result, improve the properly by virtue of kinetic energy. Improve kinetic energy, random velocity, thermal energy, etc. of the atom or particles. So this is another methods that can properly change, or by etching process. So these are the different processes we can use: polymerization, lamination, sintering. Lamination that can also protect from the outer side atmosphere, and can electrons cannot easily penetrate and can strike on the surface, so that work function cannot be reduced and can improve the quality of the product. Now the methods of micro manufacturing. Methods of micro manufacturing are subtractive process. Micro manufacturing, one is cutting, say by milling, turning, grinding, polishing, etc. in the conventional system. Even micro EDM, micro electrical discharge machine, micro electrochemical machine, laser beam machining, electron beam machining, photochemical machining, etc. There is a lot of different advanced machining processes are also the very much or side by side important for advanced manufacturing process. Additive process also. There's a surface coating, chemical vapor deposition, physical vapor deposition, metal spraying, etc. Direct writing process, inkjet, laser guided, micro casting, micro injection molding, sintering, photoelectroforming, chemical deposition, polymer deposition, stereolithography. Lot of all are the advanced additive processes, which is become important for the advanced manufacturing process. Even deforming processes, say microforming, stamping, extrusion, forging, bending, deep drawing, incremental forming, superplastic forming, hydroforming, electrohydroforming, hot embossing, and micro nano impressing. So now there is one of the important things over here. These are become the all advanced processes. So just like a hydro electroforming, hydroelectroforming or electrohydroforming, it is a hybrid process where hydraulic pressure, that is by the fluids or by water, which can use in a different set of cylinders or intensifier, is nothing but that which can use in a different stages of the liquid and water, can improve the enormous amount of pressure which is not possible by a simple pump. Even an irrigation pump, not possible more than 100 to 150 psi. Here you can develop up to 400 megapascal. That is very much important. So that type of equipment use side by side the use of electrical current and some capacitors, which is become hold the maintaining a gap, hold the charges. Now gap is very nearer to each others, and then electrons try to jump from one to the other element, and thereby the potential difference is reduces, and apply the pressure on this particular water, and then high pressure is applied on your plates or the metal which we are interested to bend or make into the shape we desire by forming process. So this is a you can say hybrid process. Hybrid means one is hydraulic as well as electrical. So even the you can say that some of the your explosive are also, that is explosive for me, that is explosive are also used under the water, and you explode the under the water, say water will become vibrate, and this undiminished pressure has been transferred, and that transfer pressure is striking on the plate. If you put the plate on a die, in between there is some gap, so the pressure striking on it in the vibration like this way, and that become bend the plate in a very you can say it is good surface finish without any flaw. FLAW, flaw means it is like a peaks and valley. There is without any peaks and valley. It is a very good surface of bend can possible by such kind of hybrid advanced technology of forming. Similarly, many of the machining process, many of the your casting process, which is become bottom bottom up process and bottom down process, basically two advanced process. One is the bottom up process is you put some wafer nothing but that electronically it is so called, it is a just like a potato chips. Similarly, it is a chips made of silicon oxides, and that is become put on it. Now you put the dropwise of the metal melting on it, and then allow with the laser beam, so that can flat and immediate drive oxidize or hydroxyl ions can take side and can deposit it on the surface layer upon layer by the different materials, so that we can get the very good electrical properties, electrochemical properties, and lot of properties, and even conductors, semiconductors, and lot of things. So called we can make a smart material of chips, which is become used today for a small or nano level parts. So these are the examples. Actually, audience is required. There is a good result required audience. That type of lecture is not good, because I can give a lot of examples, and so that it is very much important for the student, those who are present. Anyhow, methods of micro manufacturing. That is another important thing is joining processes. Micro mechanical assembly, that is another important thing. Laser welding process, resistance, laser, vacuum welding process, bonding and gluing. Gluing process, nowadays a lot of gluing process we are using. So that can also join basically if you want to manufacture the stereo lithium batteries. So lithium batteries today, we are replacing your lead acid cell. Lead acid cell, say 12 volt battery, we need the 13 plates. And this 12 volt battery weight at least 25 kilogram. Oxide battery as usually. But if I want to make a lithium battery, lithium cell battery, so lithium or galvanized, so that is we can get in that cases your weight only 2.5 kilograms. So that can only possible to make the between two plates make some gap, that is some insulator plates. Then insulator plates should be a fiber, say maybe glass fiber epoxy composites. So that we have to require to manufacture the glass fiber epoxy composite by the some of the advanced processes. That is not possible to manufacture by your conventional process, because once is the fiber, so that is, say you can say it is a fiber maybe 6 to 7 microns, maybe 20 microns. So these are become these also manufacturing required a die when you process the gel with the silicon. So make this fiber, that fiber put on the plastic. So that's why we need some advanced machining process to make the die first of the whole of 5-6 microns of dimensions. So That I am coming one by one. You people can easily understood what is the importance of the advanced manufacturing processes. So then now the hybrid processes. What I am talking now, the hybrid process. It's a micro laser electrochemical machine. Micro laser electrochemical machine. Laser assisted jet electrochemical machining, laser assisted electrochemical machining, and only electrochemical machining. There have a different machining process. Electrochemical machining itself is a non-conventional machining process, and laser assisted, it is a hybrid non-conventional machining process. Chemical machining process, one is another electrochemical process, that is chemical and electrical action, both. So called, it is a one sort of hybrid process. Again, you become attached with this laser. So laser beam is striking on the surface, thereby excited the surface, and the surface become reduces their total energy, losses the work function, and ultimately irritate and certain discharge of the electrons and holes from the surface. Thereby we can, ablation can be takes places from the surface, and metal can be removed by this particular hybrid machining process. Another important point is here the lithography, Galvani Sarman AB Forman. That is also the Germany name, and the Liga combined with the laser machine. Liga also, there are some of the deposits only the various substrate that I will showing some 1-2 pictures, and micro EDM and laser assembly, laser assisted micro forming. Yes, you striking the laser beam, and then we apply the very small pressure, not pressure from above the surface, from the bottom surface create a partial vacuum, and once you create the partial vacuum, we applied the laser beam on the top surface. So therefore the plate or wafer can be bent, even it is maybe a non-conductive of this material. But the non-conductive and brittle materials are not possible by the conventional process to bend into this, but here can possible to do it. So these are the most important things, and combined of micro machining and casting. Also I have given one of the examples, the micro casting, that is also can possible to upgrade bottom up process, where we can deposit the material and ultimately we can make a thin chips, thin section chips, by depositing the different chemical compositions and getting the more advantages, increase the surface area, and a lot of things are advantages over there. And here micro manufacturing machines and tools. Now the question is become, what are the micro manufacturing machine and tools? The Mechanical Engineering Laboratory under the National Institute of Advanced Industrial Science and Technology succeeded in year of 2000 in equip a micro lathe machine with a precision digital control system. So the digital control system are also used to operate the lathe machine of the micron dimensions machine. And even Desktop Factory study the group of Nanotechnology Foundation Consortium, and the group is composed 14 companies and several institutions. They developing the concept of micro factory in order to importance in its into manufacturing activities. In 2003, they developed a unique desktop size turning center, of which the machine is only about the size of an A3 sheet paper. A3 sheet paper machine the people have developed and used for various operations in 2003. Now 2004, say miniaturization of the conventional milling and turning process. So the servo and machinery manufacturers, France is Franco, in 2004 they developed a machine with several combinations of high precision multifunction called nano machine with feet of robots, so that can automatically these functioning of this, some temperatures aspects, some wear aspects, some chemical aspects where the human cannot work, the robot can work, and that area are also important to use today's and even research. So which can function as a 5-axis mill lathe 5-axis grinding, 5-axis shaping machine, and high-speed shaper. These being realized by means of an air turbine spindle instead of a conventional rotary servo motor. Not conventional rotary servo motor is used there. Air pneumatic turbine operated. Air compressed turbine spindle is used to reduce the vibration. Otherwise, you use the motor, there have some loss of electrical current, loss of I square RT, copper losses, and many things. So whatever maybe you are supplying, there have a fluctuation, there have a not possible of proper actually smoothing through SL, and so that can be eliminated by this process, and the reduces the vibration, reduces the your fluctuation of machine speed. This type of machine also developed in 2004. Now 2006, a group of researchers from the University of Strandale, they developed a microforming machine. This machine is driven by a direct drive precision linear motor and has a capability of mass production, 16 parts in every second. Even 16 operation in every second can possible to form is the desired shape. Microforming operation was fully automated, and where the high precision feeding and parts transport systems were fully integrated with the machine. Even a linear motor driving mechanism was used, and the maximum frequency of the machine is 960 strokes per minute, that is SPM, and the maximum force is 5.3 kilonewton. The vertical position revolution is 0.1 micrometer, and the load measurement resolution is 0.1 Newton, and the machine enables to micro stamping, forging of sheet metal parts thickness less than 100 micrometer. That means 100 micrometer, you understand, 0.1 millimeter only thickness sheet. So that is also a challenge to manufacture of the 0.1 millimeter of the thick sheet. That machine has maximum working space is only 400 millimeter by 400 millimeter. That is 40 centimeter by 40 centimeter only working space. So this is a very small machine. That machine, so that type of plate we can use for micro level product. Power is changeable without need of changing the machine components, even a motors. Now the manufacturing of micro-mechanical components. Manufacturing of micro-mechanical components, here many materials used in the to build microsystem. To build the microsystem, many materials are basically used, just like a silicon, plastic, glass, ceramic, metal, etc. Even many aspects, that is safe, electrical properties, surface properties, optical properties, all properties nowadays are very much important for the different products to product design. Now the many manufacturing technologies applied and combined, say lithographic techniques combined with etching and deposition of material. Etching is nothing but it is a process of removal of material by chemical action, by heating, by laser action. And the deposition of material, as I said, microcasting is also one of the process deposition by polymerization or by electroplating. So these are the different processes for deposition in the micron level on a particular substrate. Wet etching and dry etching, both two kinds. In the chemical, whether electrolyte with the acids, or dry etching also by striking of laser beam on the solid surface, by making a vaporization on the surface, an atom can be liberated from the surface. So that can also is a dry etching process. Even chemical vapor deposition, then your plasma enhance, PECVD, plasma enhance chemical vapor deposition, sputtering, etc. These are the different methods can be applied to the advanced manufacturing process for manufacturing of the component. Even mechanical machining, laser ablation, I have already explained. Use the laser, we can remove the material from the surface by using the laser beam. Say remove of the material from the solid surface by irradiating of the surfaces. That is laser ablations. This process can also be used to remove the material. Now the question is become, what are the process we will use for fabrication of the product? So the processes are liquid phase approach, solid phase approach, and two phase approach, liquid and solid. Just like I given you one of the liquid phase approach, say we want to manufacturing of composite materials. Say composite materials have both the things are there. One is the matrix, another is the reinforced particles or reinforcement fibers, whatever may be you are using. So that matrix material must have to be melt in a low melting temperature. So let us example aluminum. Aluminum a melting point only 660 degrees centigrade. Now you can melt it 660 plus minus 10 degree. So 670 degrees centigrade you can melt it. Though furnace temperature usually maintain 710 plus minus 10 degrees centigrade when you are going to manufacturing of the composite materials. And at the same time, see if you use the silicon carbide or alumina or zirconium oxide, or you can use the nitrides or titanium boride, whatever may be the particles you will use, that is so-called reinforced fiber particle. So reinforced fiber are hard and very high melting point. Just like a silicon carbide is too much harder than that of the tungsten carbide. Though melting point is 2750. So that in that cases, we cannot melt together mixed aluminum and silicon carbide together in a furnace. Then the aluminum will start to vaporize even 900 something degrees centigrade. So therefore, we should not go for this. We go for first aluminum is put into the ladle and the ladle plates inside the furnace. Say let us capacity 1000 degrees centigrade and allow for 2 hours, maintaining the temperature of 710 plus minus 10 degree. So that can it is become melt, and then another furnace simultaneously will use where we can put with another ladle of the alumina or silicon carbide or both together. If you want to make the hybrid, you can both together put and for agitation of 2 hours. So the agitation temperature at least you should maintain 1250 degrees centigrade, that is above the recrystallization temperature of this particular reinforced material, and then you allow again 2 hours at that temperature, then you taken out after 2 hours this agitated material, put into the your molten aluminum as a matrix, then you stir it and then you put into the prepared cavity or metal mold cavity. That metal mold cavity also simultaneously is required to baking operation, that is agitation. Baking means you have to remove the all hydroxyls which are very much important, otherwise it will become oxides form or gases form and the blowholes may occur and defects may occur in the casting. So thereby after stirring you can put into the prepared metal mold. Metal mold must have to be clay coating and then baking and then put into this particular place and then put the molten material over here, then allow for solidification. So this has become a process of the composite casting. This process is known as liquid phase approach. So that means we first melt and then make into liquid and then become solid reinforced agitated particulates placed on it and then allow for solidification and then solid material taken out. So this is one of the important process or fabrication process of the raw material of composites. Say you can manufacturing also even hybrid composite also from this. Now next is solid phase approach also. So solid phase approach, say in the C2 process or in a gas process, lot of the process are solid phase. Just like you can see the powder metallurgy process we can use. So there only you first make the powder form by the different process. We have a different processes powder form. So that rotary process, chemical process, and many of the milling process, chemical process, and many things, carbonizing process, and a lot of processes which people can use. Crushing process also. By ball mill you can use and crush this material of the brittle material and can make into the small powder forms, and then powder forms material can put together in a die and then apply the pressure through cold or through hot isostatic and all these process. So these are of course process for making in the nano level parts by the solid phase approach. So this is one of the another important approach also, solid phase approach. And two-phase approach both the cases, the liquid, and after solidification then it will press and then allow for solidification for improve the specific gravity, that is for, you can say it is density. So if you improve the density, that obviously the compactness of the molecule will increase and thereby increase the you can say the product quality or the attractional force between the molecules. So the other common fabrication, everybody knows it. So I am not going this. Now I am going to the more advanced. Now the advanced fabrication. Advanced fabrication is basically two types. One is macro fabrication, another is micro fabrication. Nowadays also another added is the nano fabrications. So that macro, micro and nano fabrication. So now the macro fabrication is the process of fabrication of the structure or parts or product that are measurable by naked eye, that is greater than 1 millimeter of the size. But micro, which is become less than 900 micrometer, that is 0.99 and below this, and beyond that we can go to that micro. So micro dimensional product, these are become the advanced manufacturing. Now the micro fabrication. Micro fabrication is the process of fabrication of miniature structure of micrometer level, scale and or smaller. And the earliest micro fabrication processes were used for integrated circuit fabrication, because nowadays all are the electric integrated circuit, also known as semiconductor manufacturing or semiconductor device fabrication. In the last 2 decades, micro electrochemical system, that is MEMS, microsystems, European uses, micro machines, Japanese terminology, and their subfields, microfluids, lab on a chips, that is everything on in a single chips. Even you can say your micro electrochemical system, also called metal oxide, MEMES, metal oxide micro electrochemical system. So the metal oxide electrochemical system, and these are the systems are also very much important for your micro fabrications. This is also one of the important. Another thing also, the radio frequency, RF, MEMS, radio frequency micro electrochemical system. It is referred to electronic components of which moving sub-millimeter size, moving towards the sub-millimeter size parts provides radio frequency say that radio frequency range of the micro electrochemical system. And even power means, bio means, and their extension into nanoscale. So these are become the important issues and have used, adapt for extended microfabrication methods fast panel displays, solar cell are also used the similar technique. Now the miniaturization and challenge. What are the miniaturization of various defects or devices present challenge in many areas of science and engineering? Physics, chemistry, material science, computer science, ultra precision engineering, fabrication processes, and equipment design. It is also giving rise to various kinds of interdisciplinary research. This major concept and principles of microfabrications are microlithography, doping, thin film, etching, bonding, and polishing. Lot of things are there. Etching I also explained. Doping is nothing but that it is adding of impurities to something, that is doping in spot by use of performance enhancing drugs in the spot, often to improve the, say, athletic performance, like this way. So that material performance to improve, put some drops on a specific spot. And doping in semiconductor, say, introducing impurities into an extremely pure semiconductor. Extremely pure semiconductor, put some impurities so that changes its electrical properties, even other properties. So this is usually required as so-called is doping. And bonding is another thing, is a process of development of a close, that is, say, human bonding, making friends, interrelationship, and happy. Atomic bonding, happy bond to atomic cell fulfilling. That means there have no gap in the atomic cell. If there is a gap, there have a outer orbit have excited electrons, can always attach with the other electrons of the other metals. So if you fulfill to complete bonding, so that it will become the compactness and molecular forces in between the molecules to be high, and thereby it will not be destroyed or removed from the surface even after prolonged service of this particular material. So this is the important things in the challenge in miniaturization productions. Now the fabrication techniques. What are the fabrication techniques? Here, microfabrication process are property modification, that is one of the important process, by diffusion or by ion implementation. Diffusion or by ion implementation. So ion implementation is one of the again important thing. So it is a process by which ions of a material are accelerated in an electrical field and impacted into a solid. So this is one of the important process in ion implementation. And this process is used to change the physical, chemical, or electrical properties of the solid. So it is used in fabrication of semiconductor device, even metal finishing, because some of the flaw and cavities can be covered up by implementation of ion, by deposition of the metals of similar size or similar categories. Size may be different by the laser beam and can melt and deposit a layer upon layer and ultimately can make a very good surface finish. That is also a cause of ion implementation. Diffusion I have already explained. Diffusion referred to the process that tendency of molecules to spread out, as a result improve the property by virtue of kinetic energy. by virtue of kinetic energy. Say, by random velocity improving, by improving the thermal energy, extra of the atoms or of a particle or a state or in the substrate. So this is the property modification that can possible by only small chips, by striking on these. These are the advanced process. Now the patterning lithography. Patterning lithography is also another important process. Say, lithography is the micro-electro-mechanical system. Micro-electro-mechanical system. That is MEMS. Context is typically the transfer of a pattern to a photosensitive materials by selective exposures to a radiation source such as light. So just like a very irregular, complicated with a nano dimensional size, we need to make the actual shape and size. That can be possible by transfer of a pattern to a photosensitive materials by selective exposures to a radiation source, by making some light and then radiations, or by taking some image placed on this particular area. So in lithography, the image is made on a substrate. I will show you one of the picture, and on that we can make this particular shape. We can deposit it on this particular material and can make into the desired properties on this particular. Now the subtract process. This is another advanced process, because once I am talking about the advanced manufacturing process and techniques, there is not only the machining process, but also the lot of processes is advanced today are become developed. So the subtract processes, one is wet etching, another is dry etching process. So etching is the removal of some portion, not the all throughout the surface. Etching is removal of some portion of the thin film or substrate, and the substance is exposed to an etch, such as by an acid or by plasma or by laser or by chemical action, which chemically or physically attack the films until is removed. So etching is a very much important process, and we can remove, and by whether it is a dry or by wet. Wet means whether it is a immersed into the chemical action, electrochemical action, or dry it is by the heating and rise the temperature to the vaporization state, and from the spot can remove the material. So next is additive processes. Additive processes, the oxidizations, physical vapor deposition, and the chemical vapor deposition. Oxidization is the interaction process between the oxygen molecules and the other substrate. The oxidation is a loss of electrons during the reaction by the molecules, atoms and or ion. So loss of the electrons. Some of the cases are very much important to remove the electrons from the substrate or particular place or from the surface. So that is required the oxidation process. Next, physical vapor deposition. We know there is an example for a cutting tool made of say carbide. We need some your coating on the carbide tool, so that maybe carbide maybe coating by your carbonitride, maybe coating by nitride, like this way. So that is the process can make a coating on this particular surface. That is a physical vapor deposition and chemical vapor deposition. There is only the process, physical way or chemical way. So this is the methods, we can increase the surface hardness and to make into the cutting. Our packaging is also different processes are packaging for the fibering and all this. Now, micro fabrication. Say micro fabrication techniques are used to manufacture structures in a wide range of dimensions, millimeter to nanometer. How it is possible? I will be showing some of the pictures. Next, the most common microfabrication techniques, lithography, I have also explained, deposition and etching. So basically two things. Once we are going to manufacturing, one is top-down approach and another bottom-up approach. Top-down means that this is a material, we want to reduce the surface or layer upon layer surface. This is top-down, downing approach. So bottom up, this is become a wafer. We put some material on the surfaces and become layer upon layer. It will, so layer may be one material, say some impurities are required in between a layer. Then top surface require the parent metal. So we put the deposited on the top surface on the parent metal, which is become to maintain the homogeneity. But in between some other material, which is become more effective or more electrically conductive or more smart type, that we can put over here to some changes of intrinsic changes, the property may change, just like a piezoelectric dynamometer. We will use by intrinsic properties, by change the temperature, by acting the forces, say automatically can change and changes their voltage, and due to the voltage we can measure the cutting force, whatever may be actually possible. So that are the basic two methods. One is become bottom down approach, another is bottom up approach, or top down approach or bottom up approach. So most common fabrication techniques are lithography, deposition. Deposition is the bottom up approach, and the etching process is top down approach. That means by removal of the material from the top. So the micro machining and the micro electro mechanical system technologies that can be used to fabricate microstructures down to 1 micrometer have attained a adequate level of maturity to allow for a variety of means-based commercial products, say pressure sensor, accelerometers, gyroscope. So all are become these examples of this. Basically, just like nowadays we people says the electrical, mechanical, electronics, computer science. So mixed 2-3 things together. That is called your mechatronics. So that means mechanical, electrical and electronics mixed together, so called the mechatronics. Similarly, micro electromechanical systems that have the whatever may be the things are required in the nano and micron level put together on a substrate, on a wafer, and make into the desired capability to activate it to get the desired purpose or to solve the desired purpose. So, but the size is very small, not is the bigger size, because we are not at all interested to bigger size of mobile, not interested in bigger size of photography, camera, and many things. So it is very small. Even we are interested to put a camera in a hall or in a hotel, in a lounge, it is very small. Now people cannot identify, but the picture can identify everything through this small portable camera. So that's why we need is a complete in a chips, everything in a chips, system in a chips, SoC. SoC nowadays is very much important in the electronics field. So system on a chips that should be used by making the every properties, putting through dropping or putting through deposition or by etching process or lithography process on a substrate or on a particular your wafer can get or can achieve it. Now, micro and nano fabrication. A nano tool box I have just telling 2-3 times. Top down method and bottom up method create nanostructures out of microstructures, and bottom up method self assembly of atoms and molecules into nanostructures, atom by atom, self assembly, or nano imprint lithography. How to do it? I will show you some pictures that you will see, so that how the atom by atom can deposit it on a particular substrate. And top down जैसे electron beam, high resolution lithography, high cost, and all these can be possible to striking on it. Now, micro and nano fabrication. Basic micro fabrication techniques, say lithography, several times I have discussed, deposition and doping. Doping I have also tell, say in a specific doping, just like athletics, if taking the doping can perform more than he doing normally. And the electroplating also, that is some deposition on the surface, and then etching I have also explained, and substrate removal. Means fabrication technique and nano fabrication technique. These are these. Now, micro and nano fabrication, that is lithography. Lithography is used to transfer a computer generated pattern into a substrate, silicon, glass, gallium arsenic, etc. And this pattern is subsequently used to etch an underlying thin film, oxide, nitrides, etc. for various purposes, say doping and etching. And here, positive, negative, remove, solvent, improve, addition, and all these. Silicon substrate, deposited thin film, oxide nitrides. Just like a chemical vapor deposition or physical vapor deposition process. There have a deposited the nitrides or carbonitrides on the surface of the cutting edge. Similar way here, deposit the thin film, now spin photoresistance, then soft break, then align the mask. Mask, I think you understand which part we are not interested to deposit or etching the material from this particular solid surface. That area is covered by a mask, so that it will not be affected and not be removed the material from this particular area. Now we expose the wafer, which part are interested to remove material or deposited material, or even a cut, a channel or micro channel, that part are required to open, expose to the chemical action or to the laser action, and then develop the resist and the hard break, end of lithography. So these are become the flowcharts for lithography process. Like this is, you see, say, you know, put in the mask on it, then mask storage, the interferometer gives you and show you this exactly. Niche wafer. Wafer is nothing but that I have also explained. It is a slice of silicon oxide in electronics field. A wafer called the slice or substrate of a thin slice of semiconductor materials such as silicon crystal used in the fabrication of integrated circuit and micro devices. So this is basically wafer, and that can be possible fabrication. You know, you see they are having single chips based on this different small chips, just like a potato chips. Simple chips are part of into the place in the different place with their different characteristics and different conductivities and properties. So now here photoresist, say oxide, silicon dioxide used as a substrate 0.5 to 2.5 micrometer, and it is soft break by 5 to 30 minutes of time, 60 to 100 degrees centigrade. Then spin the photoresistance to the soft break, then apply the light photomask. There, which area we not interested, they put the black face, then expose the photostat again, photoresist again, and develop the photoresistance and the hard break, then etch and oxides. That means if it is, once it is developed, it is the required to remove the from surface. That's why it's required to etching to make into the actual surface and then finish it. So this is one of the primary methods we can use. This is a machine of lithography. Depending on the separation of between mask and wafer, 3 different exposures systems are available here. One is contact method, another is proximity method, that is a small gap in between the Prof and this wafer, or jet on the wafer at the case may be. Other is projection, most widely used system in the microfabrication, and can yield superior solution compared to the contact and proximity method, that is projection method. So project the actual shape and size. We have already explained in the lithography methods. So take same way that methods are used. This is a machine, how it is become working, you see. Now the fabrication process of silicon: single crystal growing, then wafer slicing, then flame deposition, then oxidization, then your lithography, deposition, and then etching, remove on the, then ion implementation. Already I have explained what is the ion implementation. Ion implement, when it is processed by which the ion of a material are accelerated in a electrical field and impacted into the solid. Then diffusion refers to the process that tendency of molecules to spread out. As a result, improve the property by virtue of increasing the kinetic energy, random orientation or random velocity, and thermal energy of the atom and particle. And after that, metallizations, and then bonding, packaging, and testing. So these have become these processes of fabrication process of silicon. This is a silicon wafer fabrication. You see the flow diagram, how it is become processed. Silicon powder, then come the machine afresh, then heating, and then make, just like you see the shape of a, you can the missile, and from it it is cut up into a slice, just like a potato slice. This is a wafer. So that that type of silicon wafer can be possible to manufacture. That small silicon wafer is treated by the various lithography and other deposition, etching, diffusion, ion implementation, and then put into the system on a chips, is a common platform chips, so that we can make the various semiconductor or even your computer chips, and which can be very much important for your operation and all this. Like this way, you see this tip includes the slide, the invert into the slices using a diamond saw. Diamond saw is using to slide into the, polish the surface and sort. So this is become the actual wafer slicing. Now the photolithography. This is another process. So the photolithography is a process by which an image is optically transferred from one surface to another. Optically transferred from one surface to another, most commonly by the projection of light through a mask onto a photosensitive material. photosensitive material through mask. And photoresist is a material that changes molecule structure when exposed to radiation. That is one of the smart material. It is typically of a polymer resin, radiation sensitizer, and sometimes of the carrier solvent. That is are also very much sensitive and changes their molecular structure when exposed into the radiation. That type of materials are only can use for photolithography operations, by which an image is optically transferred from the surface. So these are really high level, most advanced process. And etching process I have already explained. There are a dry chemical etching, a wet chemical, dry etching, plasma, spatter etching, and even your reactive ion etching, usually reactive ion beam etching, and chemical assisted ion beam etching, CAIB, chemical assisted ion beam etching, and even electron cyclotron resources or resonance, electron cyclotron resonance, that is ECR, is a phenomenon observed in the plasma etching. So again, plasma is another important thing. When a gas, you can rise a temperature of 2000 degrees centigrade, so it will break into the molecules, and again you rise this temperature beyond 3000 degrees centigrade, the atom will become broken, and these ions and electrons carrying the charges, so that form the plasma. And now this thing is become, so the electron cyclotron resonances is a phenomenon observed in the plasma etching. Plasma etching means that is removal of the material by this striking of plasma ray. So this is another process of important today. Now photoresistance removal, liquid resist, steeper cause of resist to swell and lose the adhesion of the substrate. So by striking of this, looseness between the bonding molecules, strength. Again is oxidization, that is removal of electrons by burning. It is an oxygen plasma system. That is another important process, can remove of the material from the surface and can input these more compositions of the properties. Dry etching I have also explained. Most dry etching are plasma based. They have the several advantages with the wet etching, small undercut, allow small times or lines of the pattern, or otherwise you are making a plowing group type, but not in that cases, not group type. They have a very good smooth. Even layer upon layer, you can easily remove this material from this by this dry etching process. It is a process of striking the laser or plasma on the solid surface and first break the work function by reducing the molecular forces from the atomic force on the surface, and the remove the molecules from the surface by vaporizations, atom by atom remove. So this is a very much important process. So that's why it is very advantageous, as known as dry etching process. Now the dry etching process, I given an example. You see, physical, chemical, and physical chemical both. There have a spattering first. First is ion is striking on this particular surface. Then neutron, again ion, then neutron, ion, and so that is removal based on impact and momentum transfer. Poor material selectivity, good directional control, high excitation energy, and very low pressure. So that is 100 torr. 100 torr means, say, 1 torr is 0.001 torr is 0.133 Pascal. So then you can easily determine what is the pressure over here. Now the chemical highest removal rate, but good material selectively. Otherwise, you have to put the mask throughout the surface. Otherwise, throughout surface will become damaged. Good material selectively is very much important. Then which area you are need to remove, that area you have to selectively identify properly and apply the chemicals on the specific area. And pressure is also more than 100 mTOR. 1 millitorr equal to 0.001 torr, which is equal to 0.133 pascals. Next is your dry etching. Here ion and material atom striking by extra atomic striking on the atom, and then ultimately it will become, you remove this material from the surface. So simplified representation of etching mechanism. You will see ion milling or high pressure plasma etching or reactive ion etching. And the masks are provided where we are not interested at all to cut or to remove the atom by atom material. There is a put the mask. Clear? So this is a dry etching by striking your positive ions. Because here ion beam machining, it is an electrothermal process, which is real sense use charged particles in vacuum to remove the material from the workpiece. Here, ions are formed by knocking of electrons from the atoms and are accelerated in an electric field which collide with the work surface and reduces the atomic force between the molecules and convert into the atom, and the atom can liberate or remove from the hard surface or the solid surface. This is the microchannel can possible to manufacture by this. The scanning electro microphotograph of a structure fabricated using dry etching. Comb drive actuators, that is very much important. Suspended spring, spring support, moving suspension capacitor plate, fixed capacitor plate, all can be possible to manufacture. Now, isotropic wet etching, all catalog graphic directions at the same rate. Most common formulation is mixture of hydrofluoric, nitric and acetic acids. Hydrofluoric acid, nitric acid and acetic acid. This is most common formulations. Etching rates may be very fast, many microns per minute. Masks are undercut, high aspect ratio difficult because of diffusion limits. String enhance isotropy. Isotropic wet etching is applicable to many materials besides silicons. Anisotropic wet, here in that case is potassium hydroxide and alkaline solution. That is heating typically to rate of control about 80 degrees centigrade or more, and the rate is 1 micrometer per minute. Nothing is too high rate. Now you compare with this wet and dry etching, a comparison. Limited, universal, sub-microns, several microns, fine, difficult, and these are good poor surface finish in wet etching. Obviously, wet etching we have to use the acid or the chemicals or alkaline, but in the case of the your dry etching, only we can strike the laser or a plasma. You can concentrate in the specific area and you can remove the material atom from this particular area. Volume is very limited but dry, but in case of volume of removal of material is high in case of wet etching process. Now, advanced machining methods and techniques. So here कब तक चलेगा अभी ना टाइम हो गया then we have to close. Okay, okay, we have to close now. Just today, as you write me this is a process of the advanced manufacturing methods and techniques. I am just coming to the advanced manufacturing methods and techniques. I am not going to the anything more, just only 5-6 slides I want to explain and then going to close it. So the machining process. So the machining is an essential process of semi-finishing or finishing by which jobs of desired shape and dimensions are produced by removing extra material from the blanks or work material in the form of chips with the help of cutting tools move past clear the work surface in machine tools. This is a definition. But advanced machining process are advanced micro machining, that is macro, micro and nano finishing. So advanced micro machining process are mechanical force, ultra utilization of direct energy and electrochemical or chemical reaction. These are the things known by thermal micromachining or by chemical and electrochemical micromachining. So non-traditional machining is very quite known, you people known, so I have not gone through this. Composition is also this. Here in that cases the direct vaporization or ablation. Laser machining is localized non-conducting machining, almost reacting with the force-free, not heat-affected zone. Force in laser machining are in micro scale, but in the conventional machining they have a obviously as a contact process and they have a mechanical stress induced in the tool and all this. Now this is the process of non-traditional mechanical: ultrasonic machining, water jet machining, abrasive water jet machining, and here in that case is electrical discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining, and all these. That is photochemical machining, PCM, chemical machining, electrochemical machining, and all these. These are become the electrical processes. So now the mechanical have the say equipment use or whatever may be. This is are the very much important for the, it is a mechanical base. Just like you can see abrasive particles, you would strike on the work surface by means of pneumatic, hydraulic, so that can mechanical strike the force on the surface. That's why it is a non-conventional advanced machining process. Now EDM or EDM, there is also, you know, it is a electrical discharge machine. Next is chemical, electrochemical machining process also. There is chemical reaction with the electrical action. The material is removed by dissolution of the material separated from the cathode and anode by a electrolyte, thin film of electrolyte. So the thermal based process, laser, I have already explained laser and plasma beam machining, electron beam machining. In this process involves the generation of beam of rapidly moving electrons in an electron gun. That means high velocity of electrons is achieved by using of accelerating voltage of order of 100 kilovolt. Narrow beam is produced and sprayed on this at vacuum. So this is a electron beam machining. Now this is ultrasonic machining process. We need the abrasion and this is the cutting, both the action with the vibration and then cutting by a jet fluid or by through mechanical vibration in the media. Now the thermal based non-traditional process, electrical discharge machine, electron beam machine, that means discharge, plasma, dielectric, then workpiece. Here electron beam and then electrons, vacuum, and already I have explained it. Electrical discharge machine, material is removed by rapid and repetitive spark generated between the electrodes and anodes, anode and cathode, separated by a thin film of dielectric media. So this is very simple thing. So these are the process also we consider as the advanced process. Now the chemical and electrochemical based non-traditional machining process, electrochemical machining process, electrochemical deburring, ECD, deburring process, and chemical drilling, CD process also. So this is also an important process nowadays for etching and electrolyting is used on the workpiece. And the micromachining, different micromachining process. So electrochemical micromachining, steam drilling process, steam tube, microchemical drilling, chemical drilling, jet electrochemical drilling, and these are the process are also your electrostream drilling, ESD. These are the lot of advanced processes. Capillary drilling, CD process also we can use. Chemical drilling and capillary drilling. There are two things. The chemical things are become striking through a capillary orifice, through a small orifice of channels. And this is the electrochemical deburring process. How the deburring process you will see over here. Tools, isolation, streamline, electrolytic steam, and on the edges where the bars or something are become present in the conventional machining process, that can be removed and debar. This is a very fine way. So these are become the advanced processes. Thank you very much. So any questions, audience?